Welcome back, reinforcement learning. This session I explained the topic is tackling more complex problems with actor-critic methods. Okay, tackling more complex problems with the actor-critic methods. It is a combination of two methods. We already discussed policy functions in the last sessions and value functions, where the learnings based on the value functions, learning based on the policy functions we have learned in previous lectures. Okay, this lecture the tackling more complex problems with the actor critic methods. It is the combination of two methods, the value functions and policy functions. The methods are combination of both value functions and policy functions. Okay, the actor critic methods are significant advancement in reinforcement learning. It is handle the complex problems by the combination of two methods, the policy function based learning and value function based learning. The policy function like a reinforce algorithm, the value functions like a Q learning, deep Q networks. Okay, the benefits of the both value functions and policy functions we are using to solve the complex problems, that methods, the combination of value functions and policy functions is called a actor critic methods. Okay, these methods we are using to solve the complex problems in reinforcement learning. Okay, in reinforce algorithm, it is a policy based learning algorithm. Here we update the parameters after entire completion of the episode execution. Okay, after completion of episode means the starting stage to ending stage. We reach the starting stage to ending stage, that is called one episode. We update the parameters after completion of the episode. So the reinforcement algorithm is called episodic type of algorithm. The problem is the learning is slow and the rewards variance also very high. So the limitations of reinforcement learning is it can be used to solve the simpler task. We already explained it is suitable for simple problems, reinforce algorithm. It is not suitable to complex problems. So the nature is it is inefficient learning and slow convergence. That is the problem in reinforce algorithm. It updates the parameters after completion of episodes. So that's the problem. So that's problem we solve by using the combination of policy function with value function. So that is called actor critic models. In actor critic, actor is a policy function, critic is a value function. The actor function is the policy function. It is it is identify the actions. The actor refers to the policy function that select the actions. The critic function, the value function evaluate the action, the what action chosen by the actor that is evaluated by the critic. Critic is a value function. Okay, by estimating the value of that action. This combination allows the stable learning and efficient of the model. It increases the efficiency of the model. The sample efficiency, we combination of the value and policy functions automatically improve the policy models performance and reduce the variance. Okay, it is also used to stabilize the learning, and stabilize the learning, it is stabilize the rewards. So it is also stabilize, updates the stabilize the rewards is influence the variance of the rewards loss and direct sampling. Okay, we are using different methods in Q learning, epsilon, greedy, softmax selection approaches we are using in Q learning. Instead of using the separate approaches, we are directly using samples by the actor critic method. It is a combination of the value function and policy function. So the advantage function we are using here, this advantage function we are using to how the actor method select the some action, that is action is how much it is better with other actions is that is measured or that is calculated by using advantage function. This advantage function helps in fine tuning the policy more effectively. It quantifies that action is the compared with the other actions. Okay, it is increase the stability of the learning and faster learning, and it also increase the efficiency of the model. Here in Actor-Critic method is a online learning. We are generally using batch learning. We are using online learning. The parameters are updated incrementally. The parameters are updated incrementally. Why it is a online learning? The parallelizing training. The models are trained with parallelizing instantly. The multiple models, the samples of the models are trained with parallelly. So this is the some features in we are using in Actor-Critic. Actor-Critic uses the advantage function. It evaluates the action chosen by the actor compared to other actions, and it is online learning, and it is training is parallelizing training. The combining value and policy functions. Here we combine the value function, that is the value function is the Q learning. Q learning one of the value function. Here we are using separate policies to choose the actions. That is either we are using epsilon greedy approach or sort my selection approach. Instead of using separate approach, we are directly select the samples. And policy gradients, it is a episodic update the parameters. Instead of episode update parameters, we continuously update the parameters in Actor-Critic method. Either actor is a policy function, critic is a value function. Critic is a value function. Okay, actor learns the select action by optimizing the probability distribution. The policy function output is the probability distribution values of the actions. The critic is a value function. It accesses the action taken, providing the feedback that improves the policy efficiency and stability. So we are using the formula policy loss function. We are using to minimize the negative log probability. The log probability we are using for the loss calculation, and we are using advantage function. It helps the action, the selected action is compared with other actions in order to in order to reach the goal. So Actor-Critic method is it has a significant advancement in enforcement learning by combining the advantages of the value function and advantages of the policy functions to solve the complex problems in reinforcement learning. Thank you.